Hi everyone, welcome back to my another tutorial series where I will try to create a custom crypto trading environment from scratch. Actually, this will be a Bitcoin trading bot example, and I don't know what I can reach with it, but actually this is the first tutorial. Now, in this tutorial, we'll write a step-by-step foundation for our custom Bitcoin trading environment, where we could do further development, testing experiments, of course. So I'll begin that in my previous LunarLander and BipedalWalker, both of these tutorials, I was gathering experience. Actually, I can open it. I was gathering experience in writing Proximal Policy Optimization algorithms to get some background to start developing my own reinforcement learning environment. The mentioned tutorials were written upon OpenAI gym package, which allows us to experiment with our own reinforcement learning algorithms upon a ton of free environment to experiment with. These OpenAI environments are great for learning, but eventually we will want to set up an agent to solve the custom problem. To do this, we would need to create a custom environment specific to our problem domain. When we have our custom environment, we can create a custom reinforcement learning agent to simulate crypto trades. This is the first part of the coming tutorial series, so this and the rest of tutorials related to this article will be available on my GitHub page. Of course, I will add a link on my description in video. So, the introduction, you can see how my reinforcement learning agent learned to run. Actually, you can visit this tutorial actually to read about it or watch my YouTube tutorial where I talk about it. So, let's begin. First, let's learn about what exactly is the environment. And the environment, I'll begin with a clean environment, and which contains functionality to run an agent and allows it to learn. Each environment must have implemented the following interface, as you can see here. So in this constructor, we first define the type and shape of our action space, which will contain all of the actions possible for an agent to take in the environment. Similarly, we'll define the state size, which contains all of the environment's data to be absorbed by the agent. Our reset method will be called periodically to reset the environment to an initial state. This is followed by many steps through the environment in which an action will be provided by the model and must be executed. And the next observation return. This is also the place where the rewards are calculated. Well, but more about this later I will talk. And finally, there is a render method, and it might be called periodically to print a rendition of the environment. This could be as simple as print statement or complicated as rendering 3D environment using, for example, OpenGL. Whenever you want. For this example, I'll begin with a print statement, but my plan is later to do everything in Matplotlib at least to make a beautiful charts of our prices. So, as I said, I chose to use a Bitcoin as for my trading environment, and of course, I'm not going to trade a real Bitcoin. This will be simply a dataset chosen as example of Bitcoin. To demonstrate how all this works, I'm going to create a cryptocurrency trading environment. I will then try to train our agent to beat the market and become a profitable trader within the environment. Actually, this shouldn't be a Bitcoin, and you can choose any I don't know, market you want. You can use Forex, stocks, cryptocurrency, doesn't matter. But you must know what you are doing to know what data you have and how you should work with that data. So we'll be able to choose any market we want. So I just chose a Bitcoin as an example. So let's get started. The first thing that we need to consider is how the humans decide what trade would be like to make, what observation we do before deciding to make a trade. Usually, a professional trader would most likely look at some chart, prices, actions, perhaps overlaid with a couple of technical indicators. From there, they would combine this visual information with their prior knowledge of similar price actions to make an informed decision in what direction the price is likely to move. So we need to translate these human actions into code that our custom created agent could understand price action in a similar manner. We want state size actually to contain all of the input variables that we need our agent to consider before taking an action. In this tutorial, I want that my agent could see the main market data points that will be open, high, low, close, and daily volume for the last 50 days, as well as a couple of other data points like its account balance, current open position, and current profit. I want our agent for each time step to consider the price action leading up to the current price, as well as their own portfolio status in order to make an informed decision for the next action. And talking about actions, our agent will have action space. That will consist of 3 possible buy, sell, or hold in the current time state, because my environment will be discrete. But this is not enough to know what amount of Bitcoin to buy or sell each time. So we will need to create an action space that has a discrete number of action types. As I said, this will be buy, sell, and hold, as well as a continuous spectrum of amount to buy. This will be from 0 to 100% of account balance or position size, respectively. It doesn't matter how we call it. In this and coming few tutorials, I will not take the amount into consideration for simplicity reasons, but after we'll get some kind of working environment with the trained agent, I will try to integrate the risk of our agent by taking the amount into consideration. And the last thing to consider before implementing a custom environment is the reward. We want to promote long-term profit. So for each step, we will calculate the account balance difference between the prior step and the current step. But because I don't have a working prototype yet, it's hard to say. Maybe I will find out that a different rewarding system works better. Anyway, we want that our agent could maintain a higher balance for longer, rather than those who rapidly gain money using unsustainable strategies. So let's begin the implementation. And actually I have everything implemented, so I will just explain everything step by step. So now that we have covered and defined our state size, action space, and rewards, it's time to implement our environment actually. And first we need to define the action space and state size. That I do here, state size and action size, as I said respectively. In the environment's init constructor, the environment expects a pandas data frame to be passed that contains the stock or Bitcoin or any market data to be learned from. Adding to this, we must know our dataset length, starting trading balance, and how many steps of market memory we want our agent to see. So I define all of these parameters in our init place in following part. I define them as DQ list. As you can see, these are the DQ lists. This means that our list has a limited size of 50 steps because I use a lookback window size as 50. And when we append a new item into this list, the last one is removed. So that's the whole logic. Don't worry, I will upload market history data to my GitHub page together with this tutorial code, but in case you want to download our own data, I downloaded market raw data from Bitcoin charts, I think. Let me see. Bitcoin charts. Yeah, I chose this place and Bitcoin, well, charts maybe. Yeah, I chose this. I chose the 1 hour hourly, and I took 5 months. It doesn't give me more, I think 6 months, as you can see. So simply I loaded the raw data and simply downloaded it. But if you know where I could get good data of history for around 10,000 steps for 1 hour time frame, I would appreciate if you share the link with me. Anyway, that's it, and as you can see, state size, it consists of 50 lookback window sizes, and here is 10 because here order history consists of 5 parameters that are balance, network, CryptoBot, CryptoSold, and CryptoHeld. There is a 5, and there will be a price actions. So high, low, close, open, and volume of our 1 hour time frame. So that's it. Next, we'll write a reset method, which should be called every time a new environment is created, or to reset an existing environment state to a primary. So here we'll set the starting balance to our initial balance, as you can see here. And this is set here. So I set it on reset. Define our start and finish steps in the dataset, and this is used to separate training and testing data, but more about I'll talk later. And as you can see, we create our primary step concatenating our orders and making the history of our 50 history steps actually. So that's quite easy. And why I do this reverse? So in this way, I get my 50 historical steps. I put it into a primary state, and all next, for example, states comes along. Well, it's you just need to print this out if you would like to understand this step by step. So next, our environment needs to be able to take a step actually. And at each step, our agent will choose and take their buy, sell, or hold action, calculate the reward, and return the next observation. In a real situation, usually our price fluctuates in 1 hour time frame. Well, I chose 1 hour time frame. It fluctuates in all time frames, up and down until it closes. In history data, we can see these movements, so we need to create them. I do this by taking a random price. Here, actually, random price between open and closed prices. Because I'm using my full balance, I can easily calculate how much Bitcoin amount I will buy, sell, and represent this in balance. So there is a balance, net worth, CryptoBot, CryptoSold, CryptoHeld, and so on. And this all is appended into my orders history. Also, I can calculate reward by subtracting. And I am doing this, I'm subtracting net worth from my previous step and current step. And lastly, we must pick a new state by calling next observation. And actually, this is because here is our current step increased by 1. This means that we are taking next step compared with current step. And as you can see here, I use here the current step actually, and this is my next step, and I simply concatenate it with my orders history, which we are appended here. So that's it. I'm not sure if there is something so much complicated, and that's quite easy. Also, the true and false, I chose that if our net worth decreases lower than our starting balance, this means that our agent lost the game of trading, and otherwise everything is fine. We didn't lose, so that's cool. And next, we usually want to see how our agent learns, performs, and etc. So we need to create a render function actually, and for simplicity's sake, we will just render the current step of our environment and the net worth so far. So I chose just to print them, current state and net worth, and we'll see how this changes. And as I said later, I will work on this step. Up to this point, our basic environment frame is almost complete. Now, not to make this tutorial too long, I'll create a function. I'm creating actually a function that would simulate our agent actions, but instead of doing these actions with the AI agent, I am doing them in a random manner. In future tutorials, next or another in the future, not another, but third maybe tutorial, we'll be able to compare our random agents actions with the trained agent, so we could make sure that our agent is learning something. And this is simple tutorial where I run for train episodes. It's 15 episodes as default, and here we simply reset every environment, which consists of 500 batches. And this is the main idea why I implemented this here in this strange manner. And this is used for training, and this is used for testing dataset, because when we are training our agent, we don't want to train agent with the same dataset over and over. So I implemented that we are defining our length of our dataset on which we would like to train our agent, and simply we are picking randomly 500 timeframes in our full dataset, which we pick, and we simply train our agent on these random picks. And we do this over and over for many steps, episodes, I mean. So that's it. And when I create this, here I decided to print the full average of all these episodes, of 50 episodes in this case would be, and to see how our random agent could perform. And actually, sometimes this could go into positive way, into negative way. Actually, this is random orders. And I should mention that here, when we have opened for example, buy order, we can't open sell. I mean, we can't do buy another second time because we don't have a balance. So this is why I measure if our balance is more than 0, and here I measure why if our balance crypto held is more than 0, because if we do a buy here, we now have some kind of crypto held, and then we can only do a sell. So that's it. And now we can instantiate a custom environment with a data frame and test it with our random games agent. So here is my price data, and of course I'll load everything to a GitHub. You can download this and test by your own. I set lookback window size by 50. I don't know why it's here 10. This will be history steps held in state. Then I divide our data frames. So in this kind of way to train and test frames, which respectively will be used to train our reinforcement learning agent. Also later we'll need to separate test and train environments for evaluation. So now I will create them just for fun. And finally, we will run our random games function with our created environment. So here, why I use 720? Because that's approximately 30 days. So I would like to, I will use our training data just to train our agent. And this is unseen data for our agent. So I will use this data to evaluate my model. So actually, I don't believe that it's gonna work perfectly at first, but at least we'll find out how these agents work. So here, as I said, we create a training environment and testing environment. And actually that's it. I can run train episodes for 50 episodes, and then we would see what random data our agent could get. I think we can run this. Build. I don't know, let me check this out for a moment. I must find an issue here. So I see what's wrong here. I am using here train data frame instead of training environment. So let's run it again. And as you can see, here is all my steps. It just finished running, and as you can see, while running it in random state, well, actually it went into a profit of $30 from $1,000. But keep in mind that this is in a perfect state. There is no fees, there are no some kind of, I don't know how it's called, but margins or slippenings and whatever. Let's run it again. Let's see how it performs one more time. Well, as you can see now, it got even 3%. Well, I would like to see a negative reward. 2%. Well, probably this was a good data set where our agent is having an uptrend. But doesn't matter. I will try a few more times at this and we'll see. Actually, it doesn't matter. But as you can see, it's something happening actually, and our agent keeps learning. Anyway, I would like to train test environment. Test environment. It's also going nice. As you can see, we sometimes can't even do these orders while we are not using a random actions, but it's fine. You can play around with it. All the code is uploaded there on my GitHub page. You can play with it. So as you can see, I don't know whatever I would like to say. Actually, this is the backbone of whole my code, and of course, this whole tutorial is just an introduction to all future tutorials, and this is just for fun to test creating an interesting custom reinforcement learning environment with some action observations and reward spaces, and it's going to take a lot more time and effort if we want to create an agent that could beat the market and make some kind of profit. And thank you all for watching. As always, all the code given in the tutorial can be found on my GitHub page and is free to use to everyone. And see you in the next part where I'll make some beautiful price charts. And of course, if you don't mind, like my video, share, subscribe, comment, doesn't matter, and see you in the next part. Bye.